Hi. So my name is Igor. At least it's written on my badge. So and today we'll talk about the API design, and I will share about the best practices. At least we consider it as the best practices, and the findouts we've got during the Magento development. So actually, it's me, and that photo that's me a year ago when I was making a presentation here on a MageConf 2016, and I was talking about the CQRS. So actually, today's topic is pretty similar, maybe, and I'm really glad that Alessandro already made his presentation before mine and share the basic concepts in the MSI, because it would be a little bit connected. But today's presentation wouldn't be particularly about Magento or MSI. So actually, this is also not about PHP, because the concept I would be talking about is valid for most of the programming languages. So actually, like in computer science, there are two really hard things. By the way, you know what are that things? Yeah, naming thing and caching validation. So today I will talk about the third one, about how to build clean and mature APIs. And yeah, so the API. And actually, why API matters. So let's raise your hands, those who have ever tried to design and build the APIs. Nice. And those who use APIs. Yeah, I believe most of you. Actually, you can't program not using APIs. You end up using some of the APIs. Whether it's library or the framework, whether it's high-level APIs or low-level APIs, you're stuck using some APIs. So why API is so crucial? Because, designing some stuff, you need to think about all the things, all the possible business case, how this particular code would be used. And with that code, with that PHP interface, PHP classes, you're supposed to cover and meet all the business requirements some particular business will have. So, and it's really hard to say whether API is good or not until it's released and until there are usages of this API. That's why actually it's mostly API could be proved that it's a good one when there are more than 3 different clients of that API. So even by this picture, you can particularly say whether it's good or not API, because you don't know for sure what the client of that API is. And the problem when you design an API and you did not think about some particular business case in advance, and you release that API, so your clients end up with finding some tricks to use your software to implement their business case and to make the things happen. That's why actually that could lead to some really unexpected behavior, like this one. So, and you can't, if you don't think about that in advance, you will be ending up with something like that. So that's why actually building a good API, a mature API, is really related to, so you need to be close to the business. That's actually why Alessandro told you about the DDD and why DDD is so important. So starting developing Magento 2, we actually start thinking about the good API. And actually we wanted to fix like all the issues we had with Magento 1, because in Magento 1, everything was an API. So we didn't have at all the private variables. All that we had was whether public or protected, and protected is also a contract, because it's a contract for inheritance. Because and actually inheritance was widely used in Magento 1, and there were a lot of inheritance, like chain of inheritance, and that was pretty typical. So that's why actually we decided to reconsider that in Magento 2, because actually the drawbacks of that approach was pretty evident, because we, any changes we made in the core leads to, we introduced some backwards incompatibilities to some of our clients. And actually it was even hard to say whom exactly we broke, and whether it was really hard changes, and it would be affecting a lot of people, a lot of merchants, or it's just okay to produce such stuff. So in Magento 2, for these purposes, we decided to introduce the service layer. So can I please to ask you, raise your hands, who is aware about Magento 2 service layer? So, good. So actually, the service layer was kind of a gate for our kingdom of business logic. The kingdom of business logic in our case is some particular Magento module, and the gate to that module is the service layer. So the service layer is supposed to provide all the possible, all the interfaces which need to be used to provide, to implement, to achieve, and to get some, all the business operation under the hood of that module. And actually, even for you as a software developer, as those guys who use Magento or extend Magento or customize Magento, so this is actually supposed to be the only place where you should look and to decide what you need to do and actually what the module responsibilities are. So, because before that in Magento 1 you had dependency on different classes belonging to resource models, blocks, templates, and your coupling to Magento core module was really high. So actually introducing of the service layer was the idea to decrease that coupling and to introduce that point, that layer that could be shown, like first of all, to see what was the responsibility of that module. And when you see, here's the example of that service layer introducing the MSI, but actually MSI is just an example. So we have this API namespace in API namespace in most of our modules in Magento. And actually, when you come to that API, you already get the awareness of what that module provides you to do. And here, actually, we have the data interfaces. So data interfaces are our DTOs, so the data transfer objects, and the services which manipulate over the data. That was the idea, and actually that's how it's implemented in Magento 2. And semantic versioning, I believe most of you are aware with the semantic versioning and that we have 3 different versions, like major, minor, patch, and major indicates incompatibility APIs, minor introduce the backward compatible functionality has been added, and the patching, for any changes we made, we upgrade the patch version. So we apply, so Magento 2 follows the semantic versioning, and each of our module now has own version, and that own version compatible with the semantic versioning. And you should know that all the backward compatibility policy applies just for the PHP code annotated with the API annotation. So what we are trying to achieve here, we are giving you a notice that if the class is not annotated with the API annotation, it's not supposed to be used in your code. If you make some kind of pluginization of that class, if you're extending that class, or, I don't know, if you're calling it in your own business logic, probably, or not probably, it will come the day when we will break you. And you will not even notice about that, probably. It could be fatal, but sometimes it could be really unexpected error. So don't do it. And actually, the worst thing in that you never know whether each particular patch update from the Magento will break you or not. So what you need to do, you need to use the API annotated classes. So here we come up to the idea of the public and private code. So what's the difference between public and private code? Actually, the public code is marked with that API annotation and private none. So actually, the idea, if you have the background developing on a C++ language, for example, so the C++ on the level of language provides you an ability to compile your sources and provide the DLL file, and along with that, the header file. And in the header file, there are like all the contracts specified, all the functions which are supposed to be used, and all the compiled sources stored in that DLL file. So actually, you can see how the particular function is implemented. What's the code which for which there is no an API in the header file. So all you end up with just the DLL and the header file. But actually, PHP doesn't provide that on the level of language. That's why all the code we have is a public one, actually. So we can't prevent you to use classes or interfaces which are not annotated with API. So you're doing it, and you're in charge for these changes, for this code. And yeah, so here are examples of the public code Magento has. So it's not just PHP interfaces and classes. There are a lot of other examples. JavaScript classes, JavaScript interfaces, virtual types, a lot of configuration, all of that examples of the public contract which you're supposed to rely on. So, and we already mentioned several times about the API and the SPI concepts. So the actually, like the API is the thing which you can just use, and the SPI is the thing for which you're supposed to provide the implementation. So, and actually, these both two things are not mutually exclusive, so it could be like both. So for example, if we consider like a product repository, so from one standpoint, if you use a product repository just to retrieve the product, update it, and save it, you are using it in a way as an API. But if you decided that you would like to improve performance of the product repository and decided to store all the products in the Elasticsearch and decided to do that on the level of product repository, it's definitely not the right place to do so. Don't do it. But you can do, because we don't prevent you to do that. So if you provided your own implementation of the product repository where you're storing all the products in the Elasticsearch, for example, and after that retrieving that product out of the Elasticsearch, you are using the product repository as an SPI. So this is actually, this is true for all languages. This is true for C++, for Python, etc., etc. So it's not about PHP. So, you know, it's kind of basic ground rule. So, and you know, why actually we're making the differentiation? Because after the code is released, both API and SPI can be evolved in a backward compatible way. But both have their specific limitation. So now we will consider that limitation. So, you know, after we release the API class, for example, or interface, we are allowed, and that would be backward compatible, to add new behavior to that class or interface. So, for example, in this particular example, we have the API class, which is released, which has a client, and that client calls the method in that class, like contract, and everything goes smoothly. And if we decide to add additional method to that contract, like new contract added to the API class, the client still works because it knows nothing about the new contract method added, but it still relies on the old contract method, and everything goes smooth. So we are not breaking, adding new behavior. But if we decide to change existing contract, or if we decide to remove existing contract, like in this particular case, if we decide to remove the contract method, so we will just introduce a fatal error to our existing implementation. That's the problem. So that's why for API, we can introduce new behavior, but we are not allowed to change or remove existing behavior. Regarding the SPI, so in case of the SPI, the post-evolutionary strategy is a little bit different, but in case of the SPI, you can remove the behavior. You can remove the method, and everything will go smooth. Because, for example, like in this case, we have the SPI interface, which has two methods, like contract A and contract B. And we have particular implementation for this interface. And after some time, we decided just to remove the contract A method. So our implementation, SPI implementation, still works. It provides the extra method. Probably that method would be never called, but it's still okay. So that's work, and that would be okay from the backward compatibility point of view. But in case of SPI, you are not allowed to introduce new interfaces. Because if you introduce new interface, you will definitely break the existing implementation. So that's the issue. So actually, the API and SPI, if you will see that in this table, it's better to have separate API and SPI, and better not to mix that all together. And if you're talking about Magento, so Magento is actually in the middle. Because modification of, so we have all of that red blocks. So we are not allowed neither to add behavior, nor to remove behavior, nor to modify behavior. So actually, we don't have post-evolutional strategy for our interfaces if they've been released. So that's why, because we don't distinguish between the API and SPI. So all our interfaces marked just with the API PHP notation. There is no SPI PHP notation. So who decides whether interface or class belongs to API and SPI? So you. So you are in charge, because we are a framework, and we provide our best class software to you for usage. And you know how you use it. You know whether you provide your implementation or whether you just use it. And based on that, you're supposed to specify the correct dependency. So if you just use our software, if you use our interfaces, you're supposed to specify just dependency on the major version of the module. But if you provide your own implementation for particular interface, you're supposed to specify the dependency on the major plus minor. And doing so actually, like, why it's matter? Because if you provided dependency on the major version of the module, you can be sure that updating your module on all the patch version of the product and the minor changes of the module will still not break your particular component. So you're a pretty safe one. So Magento guarantees that we would not break you. And here's the same, but you're free to update your module in the scope of the patch version only. Magento making each big commercial release, like 2.1, 2.2, 2.3, actually provide a list of service contracts which been updated and for which we introduce the backward incompatible changes. So now I will talk to you a little bit about the prohibited code changes, because some people from community are thinking that velocity of internal developers who work on Magento is not so good. Because sometimes on a different events all over the world, I've been asked regarding, so guys, why are you producing a few of software in each of your releases? Because, for example, our own team provides much more than you. So maybe you need to boost somehow your velocity and performance. And actually, when we start working together, like during the contribution days, the guys realize that we have much more requirements. And the backward compatibility requirements are one of those, which actually introduce quite a lot of complexity for the writing code. So one of the prohibited code changes, just to mention, and you realize what is not allowed to do Magento core developers. So we are not allowed to introduce class we are not allowed to remove class or interface, which is marked as the API. So public and protected. So currently we are talking about all the code which is marked as the API with the PHP and API notation. So we are not talking about the private code. So private, we are free to update the private code. So public and protected method removal is also prohibited. Introducing of a method to a class or interface is also prohibited. So there is pretty good example. So we have the category repository interface. And the team who was involved in working on that interface so introduced it without getList method. And actually the team at the time of development thought, so we have the category hierarchy interface, and probably it's possible to build the category to get the list of categories using the category hierarchy interface. And we released this interface in this particular state. But after some time, we got the GitHub issue. And one of the guys from the GitHub asked us, how actually I proceed with filtering the categories. So I would like to make a filter and search for the category by name. And there is no such opportunity, and because the category hierarchy interface doesn't provide that. So actually, what we end up with, so we had to provide this functionality. But we are not allowed to change this interface. We can't just bring new method to this interface because we will break some of the extension. So what we did, we introduced a new interface. So the interface with a single method getList. And actually this interface provides the getList functionality and works. And yeah, but it's totally separate out of the repository. It's not somehow related to the repository. So we are not allowed to remove static function. We are not allowed to add parameter to public method. So how actually parameters, for example, added to protected method. So protected method still has the same parameter as before, but we introduce the private method. And in the scope of that, in the scope of the private method, we make all the business logic we want to make. But the previous method, the previous contract, like protected method, supposed to call new method under the hood. So you see, it's pretty complicated stuff because we are taking care about backward compatibility. So another set of the prohibited code changes are here, and pretty interesting stuff about the constructor modification. So because the constructor is not part of the contract. Constructor belongs to the implementation. So we can add dependencies to constructor. Because, for example, even when we need to fix a bug, we don't have a lot of bugs, but some of them, open it on a GitHub. Sometimes it happens that we need to fix some of them. So, and taking into account that we have a constructor dependency injection, probably, but not probably, we definitely need some introduction of some additional classes to our existing classes. But if you will just introduce new class to the constructor dependency injection, we can break those who are using the inheritance-based API. So Magento 2 doesn't recommend to use inheritance-based API. So don't inherit from our interfaces. Use composition instead. But we know for sure that many of you still use inheritance. Yes, that happens. That happens much more than we want to happen. But but Magento still cares about those guys. So because how we actually can break those guys? So if you provide your own implementation extending our class, and you add in new parameters, and in the scope of your constructor, you are calling the parent constructor, your parent constructor, actually your new class know nothing about our changes, that we added new parameter, so that class would not pass to the parent class that new parameter. That's why actually we have this trick, like we introducing the optional parameter and instantiate it using the static method of the object manager. So it's kind of tricky. This code has a smell, but that satisfies us from the backward compatibility point of view. And another stuff, it's much, so we already have kind of static scripts which find this code. And for example, when we would be allowed to introduce the backward incompatible changes, we will just run in the script, we will fix for the whole Magento code base such pieces of code. So modifying the default value of optional argument in public and protected method is also prohibited. So you see that we are actually literally not allowed to do anything with the public code. So when it's released, it's like getting concrete. We are not allowed to do anything. So, and actually the main rule is that backward compatibility is more important than niceness and effort of the implementation. And we stuck with the problem that because you are not allowed to remove the objects out of the constructor, even if these objects are not needed for you. So they still exist in the constructor, and introducing new objects, we end up with the suppressed warnings like coupling between objects, because we have the PHP MD static checking, which prevent you there is a threshold, like 13 external dependency, and PHPMD prevents you from introducing more. And actually, when we have like 13 external dependencies, that's actually kind of smelling your code, because that's probably in this case the code does not satisfy the single responsibility rule, and it should be refactored. And actually, we must refactor our code. There is not an option to not refactor the code, because refactoring should be continuous and should be done along the development. And actually, that's why sometimes this is how backward compatible fix looks like. And actually, it works like most of the time. And so we are trying to improve the quality of such fix. So, and here probably one of the most important slides in the presentation. So, like, we come to the conclusion that good object-oriented programming, the service layer basically is a functional programming, because we need to have like constructor injection, immutable state, single responsibility principle, and uniform interfaces, and value object passed across services. And if we'll bring this concept all together, we actually end up with single method immutable objects. That's why actually that's pretty typical currently for our interfaces. So most of our new interfaces introduced, for example, in the scope of the Magento MSI module, but for other modules as well, looks like, so they're single method interfaces with the method execute. So, and actually, because we have the single method interface, we can make the name of the interface to be self-descriptive, to be logical, and the name of the interface supposed to provide the business knowledge and the responsibility of this interface. That's why actually we don't have like a meaningful name for the method, but we have the meaningful name for the interface. For example, like in this case, we have the assign sources to stock interface, or like we have the get product quantity in stock interface. And actually in this case, the method name is just execute. That's actually why we end up thinking like maybe it makes sense to not to use execute, because like in this case execute sounds like redundant and a little bit awkward, and maybe it makes sense to use the magic method invoke, and instead of like get product quantity in stock interface, we end up with get product quantity in stock interface with the method invoke. And you don't need to call the execute anymore, but all you end up with is just to call the particular implementation which you are given. That's why actually Alessandro already showed you this quiz which I started in Twitter, and like, because from my perspective, usage of invocable services was good enough. Like that's a step towards the functional programming, because we are given a source which is a functional object, which is a functor. So, but you know, we've got quite a lot of feedbacks on this particular question, and so the pros with this. So actually, the pros introducing the invoke was we just remove all of this execute. But the cons, we have cons, and the cons actually there are like more cons than pros. For example, there is no autocomplete in PHP Storm IDE accessing via this object. For example, like in this case, and you know that's also a little bit strange that you need to wrap your access to the invocable object in a brackets. So like that's not intuitive. Another stuff. So Sinisha mentioned on Twitter that here we will have two different concepts. We will have invocable services, and we have services which are not invocable, kind of like a repository, and probably it's not good to mix different concepts under the hood of the service layer. And also, like unit tests also look a little bit frustrating, because you need to pass always the array, because the invoke method accepts the array, so it looks a little bit strange. And many people don't realize how to cover the magic method with the unit test. So we decided to stay with the execute method because the process given by this approach with using the invocable methods are not covering all the concepts we are given. And repositories. So repositories is a facade we use, and yeah, so it's the facade, and actually I wouldn't even say why we use repository, because as I already mentioned, repositories are like kittens, and everybody like kittens. I have never heard any negative feedback about repositories. So people who have experience working with Java, who have experience working with the Doctrine, Laravel, all other frameworks and coming to Magento, they actually understand the concept of repositories. So repositories are great, and we use like this method in the repositories, and you would not find any other method in the repositories, because this is not a data gateway pattern. So we are not introducing all the possible methods how you can get the data for particular entity. So just a limited scope of methods could be found in the repository. It's probably not so visible, but actually a repository under the hood usually use the commands. So, and each of these methods, like save, get, delete, just proxy this method to the command. So again, like I already showed you this slide. So actually, what we finished with, and what's our current vision of the good interfaces. So we have domain-driven interfaces. And you don't even know to go inside of this interface. Just reading the interface name, you pretty well understand what actually happens inside. And of course, we are not. You actually don't even need to read the documentation for that module, because many developers consider that code is the best documentation. So, and this is true for such kind of the interfaces. So you don't need to read a lot of documentation, but all you need to read is just the interface name. And another golden rule for the providing good API design: so don't make your client do anything you can do. You can do for them. So because if you can provide the sugar method, which combines several another APIs under the hood, do it. So we need, because that will definitely reduce amount of the boilerplate code your client will write. So the implementation of the API could be sophisticated and has a lot of code, but the client's code should be easy to read, should be clean, and should be short. Actually, in the previous months, Magento written several articles in the PHP Architect magazine, and one of that article is the common and query API design in Magento 2. So I've written that article, and actually all other articles also great. So this issue of PHP magazine is free of charge. You can just download it for free. So Magento paid for that. So just if you want to be familiar with Magento concept, you can just download that magazine and read it when you have a time. So that's probably all.